Let's consider four vectors given by vector A, vector B, vector C, and vector D. Now, we want to find out the scalar product of four vectors, of these four vectors. How do we define it? First, we need to define. So let's say we take the cross product between vectors A and vector B. So this is going to give us a vector. Then we take the cross product of C and D, and this is going to give us another vector. When we take the dot product between these two vectors, it's going to give us a scalar product, scalar value. And this is the reason why we are calling it a scalar product. So this is the scalar product of four vectors A, B, C, and D. Now we're going to find out what's the value of this particular product is going to look like. So for this, let's start by considering the vector, the cross product between C and D vector, to be equals to a vector R. Now that means R vector A cross B dotted with vector C cross D. This becomes equals to vector A cross B dotted with vector R. Now we know that the scalar product between two vectors is commutative in nature, so this can be also rewritten as R vector dotted with A cross B. So that means in a compact form, we can rewrite this as vector R, vector A, vector B. So this is the notation for writing a scalar triple product between the vectors R, A, and B. But we know that the vectors in a scalar triple product are cyclical in nature. Cyclical in nature in the means. So if we have the vectors R, A, B, so they are going to be following this particular cyclic order. So that means we can also rewrite this given scalar triple product in the form. So we have R going to A going to B. So this is equivalent to saying we have A going to B going to R, means the same thing. Now what we do, now that we have this particular form, we will again expand this. So this will become vector A dotted with B vector cross R vector. The whole reason of doing this is because now we will use the value of vector R. So that is B vector crossed with R vector, which is C cross D. And what we have now here within the parenthesis is the vector triple product between vectors B, C, and D. Now, we have already covered what is the expansion of this particular vector triple product. So let me state it. So let's say we have three vectors, vector A, B, and C. Then vector A crossed with B cross C. This will be a vector triple product between these three vectors. So this is given by vector B. We'll start with vector B, then multiply it to the dot product between A and C, minus, then we take the vector C and multiply it. This will be simple multiplication, multiply it to dot product of A and B, and we can use the mnemonic back cap. So we're going to use the same mnemonic technique to expand the vector triple product between B cross C cross D. So let's do that. So here we're going to write ABC. This will mean that this particular vector A is represented by B vector is represented by C vector, and the C vector is represented by D vector. Now let's apply the backcap method. So we'll be having, so we have B, so this will be C vector multiplied to the dot product between B vector and D vector, minus, so we have this C vector, so this was D vector times B vector dotted with C vector. Now let's multiply, or let's distribute this vector A with each of the two vectors within the parentheses. So this will become A vector dotted with C vector. So this is now multiplied to B vector dotted with D vector, minus, So we have A vector dotted to D vector times B vector dotted with C vector. And this result perfectly makes sense because we know that A dot C, this is a scalar value. Similarly, B dot D is a scalar value. So multiplication of two scalar values gives us a scalar value. Same goes for the second term. So we have one scalar value subtracted from the other one, which gives us a scalar value. And that makes complete sense because we were taking the scalar product of four vectors, which is A cross B dotted to C cross D. However, there is a easier way to remember this, because if we look at this particular expression, which is actually a 2 by 2 determinant, so this can be written as A dot C B dot D, and we have A dot D and here B dot C. The best way to remember this is as if we are distributing A cross B with C cross D. So first we have A dotted with C, and then we have A dotted to D in the first row. And then in the second row we have B dotted with C and B dotted with the vector D. So this is how we can find the scalar product of four vectors A, B, C and D. So let's use this particular expression to determine the scalar product of four vectors with the help of an example. So in this particular problem, we are provided with three values of the vectors A, B and C. So we need to find out the scalar product of these vectors A cross B dotted to A cross C. So let's rewrite this particular expression A cross B dotted to A cross C in the determinant form. So this will be, so in the first row we will have A dotted to A, then in the second first row second column we will have A dotted with C, then in the second row we will have B dotted with A and B dotted with C. So let's find out A dotted with A. So that will be A vector dotted to vector A. So we have 2, 3, negative 1. So this is dotted with itself 2, 3, negative 1. So this will give us 2 times 2 is 4 plus 3 times 3 is 9 and negative 1 times negative 1, that's positive 1. So this is going to be equals to 14. Then we have vector A dotted with vector C. So vector A is 2, 3, negative 1 dotted to vector C. So our C vector is 1, 1, 1. So this will be 2 times 1 times plus 3 times 1 minus 1. So 3 minus 1 is 2. So this is 4. Then we have B dotted to A. So vector B is negative 1 to negative 4 dotted with A vector, which is 2, 3, negative 1. So this will be equals to, so we have negative 1 times 2, negative 2, plus 2 times 3, so that is 6, plus negative 4 times negative 1, so that is positive 4. So 6 plus 4 is 10. 10 minus 2 is equals to 8. And then finally we have B vector dotted with C vector. So this will be, so vector B is negative 1, 2, negative 4 dotted to. So we have C vector, which is 1, 1, 1. So this will be negative 1 plus 2 minus 4. So negative 4, negative 1. So that's negative 5. So 2 minus 5 will be negative 3. So let's substitute this value into our determinant. So this will be, so A vector dot x. So this is 14, 4, 8, negative 3. So 14 times 3 is negative 42, minus 8 times 4 is 32. So our final value is 74. So this will be equals to negative 74. So this is the value of the scalar product of this four vectors A, B, A and C. Here one of the vector is repeating.